Hello everyone, my name is Shambhavi. Hope you all are doing well. So we had studied into the previous video about the theoretical implementation of your Q module, right? I told you that how that particular module, how we can use this over in the stacks, right? What are the different functions as in your max size, empty, full, get now await, put now await, Q size, right? For all of these functions we have discussed up in details into our previous videos, right? Now today we'll be seeing out the practical implementations with the help of the Q methods, right? With the help of this particular method, how we can do, and again with the implementation of some of the functions as in like inserting the elements and removing the elements, put function, get function. This is what we'll be seeing up into this video, right? So let's get started up over here with the implementations. Okay, so as I was discussing, that Q is one of the modules which we have up over here, right? It is a module. So as explained previously also, modules do not need out any implementation in any installation in Python. Those come pre-installed with the Python package, right? So I can very simply write in over here that from Q, right? From Q, I'll be importing up one function which is LIFO Q function. Okay, LIFO. Okay, just let me correct that. LIFO Q function, right? So when in the starting of this tax one, I told you that there are three methods about which we can use in for implementation of this tax. Right, the first one was only the list, second was a DQ method from the collections module, and third one was a LIFO module, LIFO function from the Q module. Right, so that third one we are seeing up over here. So what I did, I just imported up from my Q module, I imported out my LIFO function. Right, that is what I did up over here. Now what I'll be doing is that I'll be initializing out my Q over here. I'll be initializing out my stack. So let's say I make up a variable that is named as stack only. Okay. Now I'll be using up the LIFO Q method because I am using up that respective function from my Q module. That is the reason I'll be writing stack is equal to LIFO Q, right? And into the bracket I'm going to write in max size, and the size I'm going to give as 3. If you remember, if you had watched out my previous video, so I have already told in about the max size function, what is it for. So it helps you to denote up a respective max size, that this much maximum number of elements could be inserted up into your stacks, right? That was what max size function was helping us to do. So I inserted up that 3. In my max size function, 3 elements could be inserted in, that is the maximum. Okay, done. Now I'll be using up one other function which is print. I'll write in stack dot Q size. Now Q size again I discussed up onto the previous video, so that it will help us to show the number of elements which are there up into our stack, right? So I just simply wrote print stack dot Q size. So it asks to check in the number of elements into my queue. If I run this up over here, so just I'm getting up here as a result which is 0, and that's absolutely true because currently into my queue into my stack I do not have any of the elements, right? Let me just show you 1 second. See, print stack dot Q size, right? The size currently is 0 because we do not have any elements into my stack over here which is being defined, right? So that's the reason we are getting up 0. Now when I want to insert up any element into the stacks with the help of the Q module and the LIFO Q function, we used to use up the function which is put function. Okay, so I'll write stack dot put, and inside that I'll be writing whatever I want to insert. Let's say I want to insert D. Okay, again I'm going to write stack dot put. Let's say again I want to insert over here as E, right? Next I want stack dot put. So I just want to insert, let's say over here as F. So D, E and then F. This is what the put function is actually helping us to do over here, right? Stack dot put D, E and F. Now what will be done? I have given my maximum size as 3 for my stack, right? So maximum I can insert 3 elements into that respective stack. Fine, that's done. Now what I'll be doing, I'll be printing up my complete stack. right? So my full stack, I'll be printing a full stack like that, comma, and I'll be writing up over my stack dot full function, right? Stack dot full, it will help me to print up my full stack, right? And after that, now even I want to check in the size for my stack, right? So I'll be just writing print into the bracket. Again I'll be writing the size, comma, function I had right away used out, that was queue size, which I told is used to check in the size of the size of your stack, right? So queue size and then the brackets. So this way your stack has been defined, and now you can check in about the size of your stack also. If I run this over here at this place, now see what I got that my full stack is true, right? So I told you, when you are having up a when you have defined up a stack, whatever the size you have defined, or whatever the maximum size of your stack was there, if that has completely been fulfilled, if your stack is completely full, in that respective case you get the resultant as true with the full function. And if your stack is not full, let's say your maximum size of the stack is 5 and you're having only 2 or 3 elements, so in that case it will show you false. False means that your stack still is not completely full. For me, the maximum size was 3 and I have inserted all the 3 elements into the stacks. That is why it is showing me true, because my stack is completely full. Okay. And next we're having the size function, so stack.queueSize, and the size helps us to find in the total size of our like elements which we have in this stack, right? So total we have the 3 elements into my stack. Now that is all done, right? Now what's the next? Next is that if you want to now pop out the elements from the stack, it means that if you want to remove out the elements, right? And the order is going to be last in first out, LIFO order only, right? So I'll just write it up over here, print popped elements like this. Okay, getting down, I'll be writing print stack, okay, S will be small for stack, dot, this time it will be get. So put is for entering the numbers, inserting the elements, get is for removing the elements, right? Next is print again stack dot get. So what will happen, my 2 of the stacks will be, sorry, my 2 of the elements will be removed out from my stack. Let me show you how. So see over here, 1 second. Great. So my full stack is true, sizes 3, popped elements are, now first is F and then E. So the inserting of my elements was in the order of D, E and F. It follows the last in first out order. So the last inserted element will go first from the will go out first from my stack. So last inserted element was F, right? And the element which will move out first is my F only. So that is why first is F is firstly removed out, then E. Okay, this is how the elements will be removed out. And now if I want to check is my stack empty or not. So how will I do? I'll just use in the empty function, right? So print, 1 second, great. So now empty, I'll just try to check in that respective thing, comma, I'll be using the function which is stack dot empty. Now I know we will not be getting here true, because the reason is we still have 1 element which is onto our stacks, right? So what I got false. It means that currently my stack is not empty. And now what if I do one more thing? If I just try to remove that one also, one more element, print stack dot get one more time, and if I try running this out over here, now see what I got, empty is true. It means that now yes, your stack is now empty, right? So this is the respective method about how you can insert up the elements, how you can delete up the elements with the help of your queue module and the LIFO queue function of the stacks. So this is how you can just do up the respective stuffs about entering or removing up the elements, right? So here are all the 3 methods which are used in for your implementation of the stacks and the things. Next I'll be covering a little about the linked list also. I'll be covering a little bit of topics, or you can say functions, which we have up into the singly linked list for the stacks. right? So if you have enjoyed the video, do like this video, do share with your friends, and do not forget to subscribe out my channel. We'll see you there in the next video.